Hello students, welcome back to another video. Today we're going to continue learning about circuits and how electricity can travel as a current. First I want to go through some vocabulary that we use whenever we discuss circuits. First let's define what a circuit is. So a circuit is a closed conducting circle or loop through which currents can flow. Typically made out of wire, but circuits can exist through other materials as well. Okay, I've been using the word current a lot lately, so we should go ahead and formally define what that is. Current is the rate of charge with respect to time as it moves through a circuit. So measuring how much charge moves through something in a second is a measurement of current. Okay, the variable that we use to notate current is a capital I, and the unit for current is amperes, and we use a capital A to notate that. The next term I want to define is called the potential difference, otherwise known as the voltage. So what the voltage is the difference in electric potential between 2 points. Okay, when I say electric potential, more specifically I mean potential energy per unit of charge which is flowing through the circuit. The more current moving through a circuit means there's more charge flowing through the circuit, but the more voltage in a circuit, the more potential energy in the circuit. The letter variable that we use to notate voltage is a capital V, and the unit for voltage is also a capital V. We call this unit volts. Alright, the last term I need to define is resistance. Resistance is what slows the flow of current. The more resistance in a substance, the less current can flow through it. So yesterday whenever we were talking about conductors and insulators, conductors have very little resistance because they allow charge to flow through it more freely, whereas insulators have very high resistances. Alright, the variable that we use for resistance is just a capital R, and the unit that we use is a horseshoe shape or a capital Greek omega. This unit is called ohms. Okay, so voltage, current, and resistance are all actually dependent on each other. The relationship between these three things is described in Ohm's Law, which I'll show you right now. Okay, so Ohm's Law states that the voltage of a particular circuit is equal to the current times the resistance. Okay, so that's a very simple equation to find voltage. All you have to do is just multiply those two numbers. If we put our equation in this triangle form, we can solve for the other variables, currents and resistance. To use the triangle to solve for any of these variables, all you have to do is cover it up, and if the two remaining variables are across from each other, you multiply, and if they're above and below, then you divide. So if I solve for voltage, I know that it should be current times resistance, so I'm going to cover that up. And then those are across, so I know, I'm going to multiply those, so it's consistent. If I want to solve for current, I would cover that up, and I have voltage divided by resistance. And likewise, if I want to solve for resistance, I cover that up, and it's voltage divided by current. Okay, so here are my three equations that I can use to solve for those variables. If I know two, I can find the last one with these relationships. So this is Ohm's Law. It's very handy whenever you're dealing with circuits. Okay, here I've drawn a very simple circuit. It has a battery right here. We use this kind of symbol in a circuit to notate a battery. These kind of dashed lines, a small, big, then another small, then another big. Current flows from the positive end in this loop, and then goes back to the negative end. But from the battery, current flows from the positive end. And we use an I to notate current, as I said earlier, so I drew that with an arrow. And then here I also have a resistor. We use these zigzag lines to represent resistors in a circuit. And here I notated that this one has a resistance of 0.1 ohms. Okay, so I know the voltage is 12 volts. I know the resistance is 0.1 ohms. If I want to solve for current, I would use this equation. I would plug in my numbers, 12 for voltage and 0.1 for R. Okay, and 12 divided by 0.1 is 120. In this particular circuit, there's 120 amps of current. So that's one example of how you're going to be able to use Ohm's Law to solve for a missing variable in a circuit. That's going to be all for today's video, guys. Thank you. See you next time.